At this point, we've looked at two of the three ways to solve quadratics, and that is the square root method, and then the previous lesson was the factoring method of solving a quadratic. We're going to look at our final method here of solving a quadratic, and it's called the quadratic formula. Now, the quadratic formula is probably one of the most useful formulas in mathematics. However, it's sometimes one of the most misunderstood formulas in mathematics. So let's describe what it's doing and then use it to solve quadratics. So here's the quadratic formula. It says that if, okay, that's the first misunderstood part. The quadratic formula is an if-then statement. So the if statement is this: if you have a quadratic, ax squared plus bx plus c, and it is set equal to 0. So if you have a quadratic set equal to 0 and you want to solve that quadratic for x, then x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So what it's saying is this: if you have a quadratic, here are the solutions. But the quadratic must be set equal to 0. And what's nice is this will solve any quadratic that exists. Okay? Someone hundreds of years ago took this equation, the 0 equals ax squared plus bx plus c, and did some mathematics on it to try to solve for x, what we call symbolically. They left the a and the b and the c alone. They didn't plug any numbers in for it. And they algebraically rearranged it so that they had only an x left on one side and everything else left on the other side. So in effect, they solved every single quadratic equation that ever exists for x. And here's what they all equal. And they're all dependent upon the values of a, b, and c. So let's use it and see some of the things that come up with using it. So I've got a quadratic here. It says solve negative 3x squared plus 6x plus 4 equals 0. Well, first thing is satisfied. I have a quadratic that is set equal to 0, and I want to solve it. Well, what it's telling me is that x is equal to this whole mess of stuff. Now, what I want to do first is I want to identify what's my value of a. Well, it's the term in front of x squared, so it's negative 3. What's my value of b? The value of b is the term in front of the x. That's a 6 for me. And what's my value of c? C is the constant at the end. So c equals 4. These are the a's, b's, and c's that I can plug in to the quadratic formula to solve for x. So negative b, if b is 6, that gives me a negative 6 plus and minus the square root of b squared. Well, b is 6, 6 squared is 36, minus 4 times a, which is negative 3, times c, which is 4. And all of this, not just part of it, but all of that is divided by 2 times a. A is negative 3, so 2 times negative 3 is negative 6. So interestingly enough, we have actually solved this equation. Here is what x equals. Those are the values of x that solve this equation right here. However, I want to clean this up right here and simplify it as much as I can without getting a decimal approximation. I don't want any decimal approximations. So I'm going to first start by cleaning everything up under the radical. So I'm going to go x is equal to negative 6 plus and minus the square root of 36. Now, negative 4 times negative 3 is positive 12, times another 4 is 48. So it's ended up 36 plus 48, and all of that is divided by negative 6. So now I've got x equals negative 6 plus and minus the square root of, well, 36 plus 48 is 84. And all of that is still divided by negative 6. Now from our work with radicals, we know that we can simplify the square root of 84. Let's see, 84, I can split that up into, let's see, a 42 and a 2. I can split the 42 up into 21 and 2. And 21 I can split up into 7 and 3. So looking at what I have here, I have a pair of 2's. So a 2 comes out, but there's no pair for us, the 7 or the 3. So I leave both of those under the radical. 7 times 3 is 21. So it ends up as x equals -6 plus and minus the 2 that came out, square root of 21, all over -6. So we've simplified quite a bit. It's already a much more compact solution than what we had. However, there's still a little bit more simplification that can be done. In the quadratic formula, you essentially have 3 terms. You have 2 up top separated by the plus and minus, and then you have 1 term down below. Now, if all 3 of those terms have something in common, you can factor that thing that they all have in common out. If I look at this, the -6, -6, and I'm looking at the 2 that's outside the radical, I notice that all of those have a -2 in common. Now you might say the plus and minus 2, that 2 is positive. Well, it's both positive and negative. So if I divide a negative out of that, the positive becomes negative, the negative becomes positive, you're back to where you were. So if both of these are negative, you can just take a negative out of everything. So a -6, -6, and -2, I'm going to divide -2 out of everything. If I divide -2 out of 6, I end up with 3. So that's 3 plus and minus, dividing that 2 out, I'm only left with the square root of 21, all over, divide the -2 out of the bottom, and I have the 3. So x equals 3 plus and minus the square root of 21 all over 3. And that right there is the solution, or rather solutions, because there's a 3 plus root 21 over 3 and 3 minus root 21 over 3. Those are the 2 solutions. We could get decimal approximations if we wanted to, but at this point we're just leaving the solutions as exact. So let's try that process again on another equation. I've got a quadratic equation here. I know it's quadratic because I have an x squared. And I want to solve this equation for x. Here's the problem. The quadratic formula says my quadratic must be set equal to 0. Mine's not. But that's really easily fixed by adding 3 to both sides. So I end up with 2x squared minus 4x plus 7 is equal to 0. So now, with one easy manipulation, I'm able to have my equation set equal to 0. So let me identify my value of a, b, and c real quick. A is the value in front of the x squared. For me, that's a 2. B is the value in front of the in front of the x, so that's a -4. And c is the constant, so that's a 7, so c equals 7. So that means x is equal to -b. Now careful, b is already negative, so -4 is actually a +4. So keep that in mind. Don't let that fool you. So I've got 4 plus and minus the square root of b squared. -4 squared is a, careful here, +16, because a negative times a negative is a positive. This number here should always be positive because it's squared. Squares undo negatives, or get rid of negatives. Minus 4 times a, which is 2, times c, which is 7. And all of that's divided by 2 times a. A is a 2, so 2 times 2 is going to end up giving us a 4. So let's start the simplification. X equals 4 plus and minus the square root of 16. Now, -4 times 2 is -8. And negative 8 times 7 is negative 56. So I've got 16 minus 56, and all of that, the 4 plus and minus the square root of 16 minus 56, is all over 4. So x is equal to 4 plus and minus the square root of, let's see, 16 minus 56 is negative 40. And all of that's divided by 4. Interesting, I've got a negative under the square root. Well, if I have a negative under the square root, we know how to deal with that. If you've got a negative, we know that's going to give us an imaginary number. So the negative goes away, but what pops out front? The I does. So the square root of negative 40 is I times the square root of 40. Now we can break the square root of 40 up. That's going to be a 410. This is a 2 and a 2, and the 10 is a 5 and a 2. Let's see, I see a pair of 2's, but I don't see anything to pair the 5 with or the 2 with over here. So the 5 and 2 stay under, which is the 10. So this becomes x equals 4 plus and minus. A 2 comes out. An I also came out, so 2i root, and then the 10 is still left underneath. All of that's divided by 4. We're getting really close, but there's still one more thing we can do. Remember from the previous example, the quadratic formula has 3 terms in it. The 2 up top separated by the plus and minus, and the 1 down below. If every term has something in common, I can divide it out. 4, 2, and 4 all have 2 in common. So what I can do is divide all of those by 2. So 4 divided by 2 is 2, plus and minus 2 divided by 2, that just goes away, and I'm left with I root 10, all over 4 divided by 2 is 2. So x equals 2 plus I root 10 over 2, and x equals 2 minus I root 10 over 2. So notice the type of solutions we have. We have complex solutions. Why? Because there's an imaginary part. There's a piece in this that has an I as a part of it, the imaginary number, the square root of -1.